We've been talking about factoring trinomials into their two binomials. But what happens when we have this crazy thing that's really just a binomial? It only has two terms. That makes it a binomial, right? Well, maybe not. Because this is really a trinomial missing its x term. So we could look at this in another way. We could say that this is really x squared plus 0x minus 16. So if I want to do the box method, I'm going to be looking at this asking to myself, well, what two numbers would multiply to be negative 16? Here's where my x squared is. What two numbers would multiply to be negative 16x squared? But those same two numbers would add up to be no x's. Well, we know that really the only way to get a 0 when you're adding is to add opposites. So really all I need to look at is this negative 16. What multiplies to be negative 16? Well, negative 2x and 8x, or vice versa. We could do 2x and negative 8x. Or we could do, how about 4x and negative 4x? Oh, I think we found it. We don't need to go any further. If I add those two, they are opposites, and they will give me 0x. So that must mean that I need a 4x here and a negative 4x here. And go ahead and play your find the common factor. So what's common here? Looks like an x. What's common here? Looks like a 4. We don't know whether that should be positive or negative. What's common in this direction? X. What's common in this direction? No, definitely a negative 4. And so we know if this one's a negative 4, this one would have to be positive 4. And so that's a really nice thing. If when you see that this is a perfect square and this is a perfect square, you have what's called the difference of two squares. That's a difference of two perfect squares. And they will come out to be x minus 4, x plus 4. Really helpful. We can also look at this in terms of factoring by grouping. Pull out your common factor, you have an x. What's left? X minus 4. Pull out your common factor. What's left? X minus 4. Yay, we got perfectly common things here. Common binomials, that's our first binomial. And then there's our second one, x plus 4. And that means x squared minus 16. Just a different way of writing it. Well, what about this one? How do we deal with this one? Well, again, I see that it's a difference. So I'm thinking that these two things add up to be no x's. So this really means 4x squared plus no x's minus 9. I look at this and I say, that's a perfect square, that's a perfect square, that's a perfect square, that's a difference. Difference of two perfect squares, yay. Which means that this is going to factor very easily into two of the same thing, because if it's only when I have two of the same thing will I end up with 0 x's. So what makes 4x squared be the same? 2x and 2x. What makes 9 be the same? 3 and 3. And how will I make them be a 0x? One of those would have to be positive and one of those negative. Done. You can even do it backwards. I could have 100 minus 49x squared. I don't care that that's backwards. I don't have to rearrange that. I can just say, oh, that's a perfect square, that's a perfect square, that's a perfect square, this is a difference. Difference of two squares. Good. Then I'll find what number multiplies to be 100? 10, 10. What number multiplies to be 49? 7. 49x squared. 7x, 7x. The only way to make that middle term disappear is to have one of those be positive and one be negative. Done. But wait, if you order before midnight tonight, you can get something really interesting. Take a look at this. Is this a difference? Yes. Are these perfect squares? Not all of them. X squared is perfect square, but those aren't. Oh dear, what shall I do? Well, back in the very beginning when you were learning how to factor, the first rule of factoring was to look to see if there's a common factor. Is there a common factor between 8x and 50? Yes, there is. Common to 8x squared and 50 would be a 2. So let's divide everything by 2 to start with. So if I pull out a 2, 2 times what is 8x squared? That would be 4x squared.